Greetings, this is Group 3, speaking on Chapter 8, Complex Cognitive Processes. Your students will be learning concepts no matter the subject you are teaching. For example, in language arts, they will learn adjectives, verbs, and similes. And in math, prime numbers, addition, and shapes. In the textbook, learning theorists explain that concepts are constructed in 3 ways. Let's explore them now. Think about the words prime numbers, equivalent fraction, addition. What subject comes to mind? Most would say math. This is an example of the rule-driven theory. Rule-driven theory suggests we construct concepts based on their attributes or characteristics. What is the first thing that comes to mind when you are told to think of a car? Most would think of a 4-door sedan with 4 wheels. This is an example of prototype theory. Prototype is a person's best mental representation of the category, a general construct of the concept, while exemplar theory, which is more detailed than prototype, represents the most highly typical examples of a concept. So concepts, like the square or odd numbers, are constructed based on the characteristics, and car or dog are represented with prototypes or exemplars. This is important to know because concepts are ideas based on a foundation of knowledge. This foundation is complex because most concepts have deeper meanings. For example, if I said a fish has a tail and lives in the water, a student may think a whale is also a fish. And some concepts are relational, meaning a thing exists in relation to another. I am near you, or she is far from you. This relation exists because of you, or me. This can also be said of negative and positive numbers. This concept is relational because the sign exists based on its relationship to 0, an important concept to understand when subtracting numbers such as 7 from 5. The way to approach the learning of concepts is to illustrate them as problems. A problem can be well defined, which is a problem that has one correct solution or a certain method for finding it, or ill-defined, which is an ambiguous goal with more than one acceptable solution, and no general agreed-upon strategy to reach a solution. Well-defined problems have straightforward answers, such as 2 plus 2 equals 4, or asking me directly for my mailing address. But trying to improve your relationship, or how to improve your grades, that will have more debatable solutions. But whatever the concept and however it is presented, 2 imperative elements exist in its development: experience and prior knowledge. Student thinking would be limited or superficial, as we have learned from cognitive theories from Piaget and Vygotsky, which is why teachers need to build these 2 elements. Let's look at problem solving as a framework. Then we can break down the process and guide students at each step. The framework for problem solving has 5 steps. 1. Identify the problem or goal. For example, what do you mean by improve your relationship? 2. Represent the problem by making it meaningful or restated in simpler terms or as a visual. 3. Select a strategy, a specific step or a widely applicable problem-solving strategy such as the means-ends analysis, which are sub-goals, and work successively on each, or drawing analogies, which works by comparing the present problem with one already solved. 4. Implement the strategy. Test it out. This step is where difficulties will arise and kinks are ironed out. And 5. Evaluate results. Students will think about their results, measure it against their estimates, and focus on having the results make sense. Another way to develop problem solving is to use a critical thinking method as described by Samantha Auguste from a TED Ed Talk. 1. Formulate your question. 2. Gather information. 3. Apply the information. 4. Consider the implication. 5. Explore other points of view. As a teacher, you can help them develop problem solving by being creative or having the students be creative. Creativity is the ability to produce original works or solutions to problems that are productive. A teacher can be creative by using technology in the classroom to solve real-world problems, as the group will explain in the PowerPoint presentation. As we build students to become better problem solvers, we help them build the foundation of strategic learning. Metacognition, as it is called, is our awareness of and control over our cognitive process. This helps students know what kind of strategy to use for the type of learning they are doing. This answers questions such as, what ideas are important and what are trivial? Am I taking enough notes or too many? Do I use flashcards or summaries for this material? Again, we have to stress that experience and prior knowledge is still key. Just as students need to know concepts, problems, problem solving, and critical thinking, they need to know what kind of strategies they can use during their courses of study. Widely used are note-taking, using text signals, summarizing, elaborative questioning, and concept mapping. Now that we are near the end of the journey we call the complex cognitive process, we hope as teachers to give our students enough practice, background knowledge, and experience to gain the ability of general transfer, which is the ability to apply knowledge or skills learned in one context to a variety of different contexts. A way to test concept understanding or general transfer with our students is by providing students with exemplars and having them choose correct representations, or they themselves can produce these exemplars. Or to go deeper, the teacher can have students apply the knowledge of the concept or principle to a problem to be solved. To recap, our students will need help to build concepts. We do this in the classroom by developing problem-solving and critical thinking skills, construct background knowledge and experience, engage in practice, observe modeling and demonstrations, and view forms of examples and non-examples. Happy teaching! This was put together by Group 3. We would like to thank you, our fellow classmates and future educators, for your attendance and attention to this video and our presentation. And si Zeus Maasi to our wonderful Professor Dr. Sablan for her guidance and insight as we mature into educators.